Have you ever wondered why honey flows so much slower than water? Or why ketchup sometimes refuses to leave the bottle? The answer lies in viscosity, one of the most fascinating concepts in fluid mechanics. In today's video, we'll explore what viscosity is, how it's measured, the factors that affect it, and its role in the real world. Let's dive in. Viscosity is a measure of a fluid's resistance to flow. In simple terms, it's how thick or sticky a fluid is. Fluids like water have low viscosity and flow easily, while fluids like honey have high viscosity and flow much more slowly. At the molecular level, viscosity is caused by internal friction between layers of fluid. As a fluid flows, its molecules rub against each other, creating resistance. The higher this resistance, the higher the viscosity. Not all fluids behave the same way. Based on how their viscosity changes under stress, fluids are categorized into two main types: Newtonian and non-Newtonian. Newtonian fluids like water, oil, and alcohol have a constant viscosity regardless of the applied stress. This means their flow behavior is predictable. Non-Newtonian fluids like ketchup, toothpaste, and slime change their viscosity depending on the force applied. For example, ketchup becomes less viscous when shaken or squeezed, a behavior known as shear thinning. On the other hand, cornstarch mixed with water becomes more viscous when stressed, a behavior known as shear thickening. Measuring viscosity is crucial in many industries, from food production to oil refining. One common tool is the viscometer, which measures how easily a fluid flows. There are several types of viscometers, including capillary, rotational, and falling sphere viscometers. The falling sphere viscometer works by dropping a sphere into a fluid and measuring its descent rate. The slower the sphere falls, the higher the fluid's viscosity. For more complex fluids like ketchup or paint, rheometers are used. These devices can measure viscosity under varying conditions, such as different stresses or temperatures. Viscosity isn't fixed. It changes based on several factors. As temperature increases, the viscosity of most liquids decreases. For example, honey flows much more easily when warmed because heat reduces internal friction between molecules. Pressure has the opposite effect. Increasing pressure can increase a fluid's viscosity by forcing molecules closer together, making it harder for them to move past each other. The composition of a fluid also matters. Mixing a thick syrup with water reduces its viscosity, while adding particles to a fluid like sand in a slurry increases it. Viscosity plays a vital role in various industries and everyday life. In automotive engineering, choosing the right motor oil viscosity ensures smooth engine operation and reduces wear. For example, low viscosity oils are ideal for cold climates, while high viscosity oils work better in hot conditions. In food production, controlling viscosity is critical for texture and quality. Chocolate, for instance, must have the right viscosity to coat candies evenly. Even in painting, viscosity determines how well paint spreads and adheres to surfaces. You can explore viscosity with simple experiments at home. Try pouring different liquids like honey, oil, and water, and observe how they flow. Or mix cornstarch and water to create a non-Newtonian fluid. It's fun and educational. Notice how the cornstarch mixture feels solid when you apply force but flows like a liquid when you stop. This is a great example of shear thickening behavior. Viscosity is more than just a scientific concept. It's a critical factor in countless processes, from how we cook to how industries operate. By understanding viscosity, we gain insights into the fascinating world of fluid mechanics and how fluids behave in different environments. If you found this video interesting, don't forget to like, share, and subscribe. Let us know in the comments what other fluid mechanics topics you'd like to explore next.